Hi, and welcome back. Today I learned that when a rooster opens its beak to crow, its ears also get blocked with a kind of natural earplug arrangement to protect them from the crazy sound pressure levels. It made me wonder, if you had two roosters, could one of them deafen the other by crowing in his ear when he wasn't expecting it? The moral of the story is, look after your ears, people. You only get one pair. Anyway, every so often, I see a product that just makes me think, why? In this case, why do we need a Lookahead Analogue Limiter? Of course, now I need to specify that I'm currently talking about the analog Lookahead Analogue Limiter hardware made by Hum Audio, not the digital Lookahead Analogue Limiter software from Brainworks and Plugin Alliance. I'll come to that one shortly. Anyway, before we continue, check out the pricing on this thing. Whatever the answers to my questions, it's not budgetary constraints. This is a no compromises price bracket. Now let's consider other expensive hardware units, like the ultimate one, the Fairchild 670. The real hardware will always, in a sense, be better than a plug-in emulation, even if the sound is indistinguishable, simply by virtue of being the original. And if the plug-in differs from the hardware in any way, the hardware is correct, because it's the definitive original version. Even if you think the plug-in actually sounds better, that just means you prefer the wrong version. When we consider brickwall limiters, however, there's no original analog model to use as our benchmark. Brickwall Lookahead limiters were very much a digital invention. And there's a reason for that. It's because they only really make sense in a digital context. There's no full scale in the analog world, no hard maximum voltage that we mustn't exceed even by a fraction of a decibel. That's a digital concept. So this limiter isn't limiting to full scale, it's limiting to a maximum analog voltage level, which will hopefully become full scale after conversion, assuming your converters are calibrated appropriately. So what advantages do we get by moving the limiter to before the converters instead of after? I'll assume an otherwise fully analog mastering chain, but the limiter typically goes right at the end of the chain, so it isn't going to change the number of AD-DA conversions at all. It just moves the final AD stage to after the limiter instead of before. That isn't going to make much difference, unless you're one of those people that like to deliberately clip their AD converters on the way back in the box. In that case, this device moves the clipping to after the limiter instead of before. There isn't a correct way to do this, it's a matter of taste. However, if the limiter is genuinely brickwall and already doesn't allow even the tiniest of overs, I don't see much benefit in following it with a clipper. If I do use clipping, it's usually before the limiter to catch spiky short peaks that might otherwise cause the limiter to overreact. Most analog limiters aren't completely perfectly brickwall, so it would make sense to run before a clipper. This one, however, has Lookahead and is very proud of the fact, and I'm going to assume that means it doesn't allow any overs at all. So from my perspective, this being analog puts it the wrong side of the clipping in my theoretical analog mastering chain. While we're talking about the end of the signal chain, that's where the dither usually goes, and it's common for digital limiter plugins to also provide dither options. Of course, it doesn't make any sense to build an analog dither, but neither does it make any sense to build an analog brickwall limiter, so I'm not sure why that stopped them. In theory, is there any reason they couldn't assume the output gain will be set to correspond to digital full scale after conversion, or close to it, and add analog noise at the correct relative level to dither a 16-bit signal? I'm confidently expecting that feature to be added to version 2, with the marketing going heavy on the superior sound of analog dither. Joking aside though, analog dynamics processors are inherently better than digital dynamics processors, right? Well, let's talk about that. There are two ways in which analog dynamics are inherently better. There's no aliasing, for a start. Now, aliasing is a bit like quicksand, in my opinion, a much smaller problem than I was led to believe it would be. Normal compressor settings produce very little aliasing, and abnormal settings will likely sound bad for 100 other reasons before aliasing becomes the problem. Actually, the biggest exception to that might be clipping, which can add lots of higher harmonics and start to alias quite quickly. And brickwall limiting sometimes incorporates an element of clipping to guarantee the brickwall behavior. However, Lookahead exists in limiters precisely so that they can catch the peaks without having to clip them. So I'm going to assume that the aliasing from a digital version of this limiter wouldn't be disastrous anyway, even without oversampling. So the other advantage is, this is inherently a true peak limiter. You can't have intersample peaks if you don't have samples, after all. And a quick note to all those people who claim that true peak limiting sounds worse. If you just toggle it on and off, you're not really comparing like with like, as the true peak version will be limiting more by definition. For a fairer comparison, you would need to lower the ceiling for the sample peak version so that its true peaks matched those of the true peak setting. Of course, both those issues are solved problems in the plugin world thanks to oversampling and true peak detection respectively, so it's questionable how big these advantages actually are in practice. Okay, so let's talk about the inherent disadvantages of analog, like look-ahead delay. This isn't as purely digital a concept as you might think, as look-ahead delay is an important part of cutting vinyl records. I think it's to ensure the optimum spacing for the grooves, but I've never personally cut a record on a lathe, so don't quote me. Of course, automatic delay compensation is a digital concept. The latency from this limiter isn't going to be fixed automatically like that from a plugin, and that might mean it can't double as two mono limiters in an analog mixing context. Then again, it's a tiny amount of latency, just 0.2 milliseconds, that you can probably just ignore unless it's changing phase relationships between channels. Anyway, as far as I was aware, there are two ways to do analog delay. One of them is to bounce the signal off tape, and indeed that's how records used to be cut back in the day. Of course, tape has a big impact on fidelity, and using tape delay to cut a record was equivalent to going down a generational copy of the master tape. So sometime in the 70s, most facilities ditched the tape delay in favour of digital delay lines instead. It was rather low fidelity digital by today's standards, but still way better than tape. I used to enjoy sharing that fact with analog purist vinyl buffs, but I don't anymore because it started to feel like kicking a puppy. If they've spent a fortune to imagine they have some magical analog connection with the original music, it's perhaps a bit cruel to piss on their bonfires like that. Anyway, the point is, even back in the 70s, the best solution to the problem of look-ahead delay was an ADC plus a buffer plus a DAC, or in other words, a digital delay. The other type of analog delay I'm aware of is arguably not even fully analog. Bucket brigade delays use sample and hold techniques to sample voltages and then pass them down a line of capacitors. Yes, I said sample. Bucket brigade delays have a clock speed, or in other words, a sample rate, and are discrete in the time domain, even though the sampled voltages remain analog and continuous. So, halfway between analog and digital, conceptually? Is that fair? Anyway, they're not usually known for their high fidelity. Discrete time sampling means that Nyquist applies. You can't have any content higher than half the clock frequency, and if you try, you'll get aliasing instead. So what kind of delay is used for the look-ahead in the Lookahead Analogue Limiter? I couldn't find an answer anywhere on the home audio site. I'm going to assume they don't have a tiny loop of tape in there. Not really, because the idea is too silly. Honestly, this thing is pretty silly already. More because if there was, it would be visible through a window and the marketing would be leaning into the magical sound of real analog tape. They might be missing a trick there. So is it a bucket brigade then? That would mean this thing effectively has a sample rate, requires anti-aliasing filters before the delay and reconstruction filters after it. It might invite questions regarding how truly analog this thing is and how it's better than using a digital delay. Hugh Robjohns came to my rescue with his Sound on Sound review. Apparently, if you chain enough all-pass filters in series, you can create enough group delay to create the look-ahead behaviour. That's an option I hadn't considered, and it makes sense. That certainly seems like it would be less damaging to the signal than tape or a BBD. On the other hand, however high quality the electronics, running the signal through 10 or more filter stages surely isn't as transparent as a digital delay line using modern converters. Have they avoided the optimal solution just so that the marketing can claim an all-analog signal path? And anticipating those of you who think, well, it's only the sidechain, how much does it really matter? Not so. The sidechain needs to hear the signal immediately, while the audio path is delayed. So any distortion from that delay line is absolutely in the signal path. I'm very curious to know how clean it actually measures when the transformers are bypassed and it's not doing any limiting. Has anyone out there done any tests? Perhaps the nice people at Hum Audio would like to give me one to try out. LOL. Or should I say LAAL? Okay, the next quality of life feature that I kind of expect from a limiter plugin these days is loudness metering. It's not essential that it be built into the plugin, but it's very convenient when it is. Of course, you can't measure loudness units relative to full scale when there is no full scale, but you could measure loudness units relative to the maximum analog voltage you've dialed in, which we could assume will correspond to full scale after conversion. Is it possible to design an analog loudness meter? I don't know the answer. It doesn't really matter because you could just pop an AD converter in there with a little DSP to drive the metering. I mean, that would probably cost less than an analog solution, if that's even a consideration at all, and it needn't affect the analog signal path at all. I wonder if they considered that idea and rejected it purely so they could market it as an all-analog unit. All right, I'm going to finish off my evidence-free speculation with what I consider to be the most important objection to this in principle. As I understand it, the difference between a good digital limiter and a bad digital limiter is about 98% program dependency. The good ones use psychoacoustic tricks to mask distortion and trick you into still perceiving transients even when they're hardly there anymore. When a mediocre limiter distorts noticeably, or smushes up the transients, or pumps audibly, that's because the algorithm wasn't clever enough to disguise those artifacts. Now, I know nothing at all about designing an analog limiter, and very little about designing a digital one, but it seems to me that the kind of intelligent program dependency this requires is going to be way easier to write into code than to design as an analog circuit. I will allow that in theory, probably anything that could be done digitally could also be done analogly. Why isn't that a word, by the way? But consider how trivially simple it would be for a plug-in limiter to take account of the frequency content of the signal, so that a loud event with lots of low-frequency content gets different treatment to a loud event in the mid-range or high-end. And then consider what that would entail in an analog circuit. I can't know for sure without testing one, but it seems vanishingly unlikely to me that it will have the same level of intelligent program dependency that we now find in the better plug-in limiters. And on a conceptual level, are we now trying to model a digital process with analog circuitry? Why on earth would you want to do that? We can all agree, I think, that a digital algorithm is never going to be quite the same as a real tube or a real optocell. That's okay, though, because most of us aren't about to buy a real Fairchild, and something that's almost the same for a tiny fraction of the cost makes a lot of sense. Can we also agree that an analog circuit is never going to be able to fully recreate the complex and intelligent behaviour of a good digital limiter, and yet it costs about 100 times more? Make that make sense? All right then, let's stop speculating about analog hardware I don't have, and instead take a look at a digital plugin that I do have. This is a digital emulation of an analog recreation of a digital process, and it's not making any more sense yet. First of all, why is there a true peak option? I don't mean why is there an option to turn it on, I mean why is there an option to turn it off? The analog version is as true peak as it is possible to be, so the only correct setting for this is on. Alright, what about oversampling? I can't find any options for that. Does that mean it's on automatically? Latency can sometimes give us a clue here. It's got lookahead, so of course it has latency. But 0.2 milliseconds of lookahead would be about 10 samples of latency with a 48K sample rate, and this plugin is reporting 120 samples. So I resorted to some sine sweep tests, and the results are kind of interesting and kind of confusing. First of all, here's a sweep that's not hitting the limiter threshold at all, with the transformer option turned off. And it's definitely not completely clean. There's a single harmonic visible, which reflects down from Nyquist as aliasing. I'm going to assume that these artifacts are from the modelled analog delay circuit. For reference, here's the same sweep running through Pro L2 with no limiting. Alright, let's try the same test, but with the transformer switched in. That harmonic from earlier is still present, and still reflects down from Nyquist, but now we have a bunch of other harmonics that don't, which is a bit strange. I guess the transformer is oversampled or anti-aliased in some other way, but the analog delay model is not. Okay, same again, but with some gain reduction from the limiter and the transformer bypassed again. Quite a lot of harmonics from that, which seem to be reflecting down from Nyquist with no mitigation. So I guess they got the transformer right, but didn't bother with the rest of the plugin. I wasn't entirely satisfied with that conclusion, so I took a look in Plugin Doctor. Here's a linear analysis, and there's a couple of interesting things to note. First of all, this low-frequency response that resembles a resonant high-pass filter strongly suggests a transformer model, but the transformer option's turned off. Perhaps there's a second output transformer that's non-negotiable, or perhaps this is the modelled analog delay, which just happens to look similar. If I turn on the transformer option, that low-end bump actually gets tamed slightly, but otherwise this response is totally unsurprising for a transformer model. The other interesting thing is the low-pass filter at the high end. This looks exactly like an anti-aliasing oversampling filter, and that's not surprising with the transformer switched in, as my sweep test suggested oversampling for that part of the code. The surprising part is that it doesn't go away when I turn the transformer off. That filter doesn't seem to change, and yet I was definitely seeing aliasing in the sweep test. If I increase the test sample rate, that filter moves to stay at Nyquist, and also gets progressively gentler. I would be convinced this was oversampling were it not for my earlier test. Perhaps this is a bug. Maybe all the code is supposed to be oversampled, but a mistake was made somewhere and it's only working for the transformer. I'm not sure what else to make of it. While we're here, let's give it a quick Hammerstein test. Here we are with the transformer off and no limiting. No real surprise here, just one strong third harmonic. Until I scroll down to the bottom of the dynamic range. We're deep into definitely doesn't matter territory down here, but I can't help being slightly alarmed by this level of funkiness regardless. With the transformer turned on, those higher harmonics become properly significant and much less funky. This seems kind of normal. But check out this response, with just 2 dB of gain reduction from the limiter. Those low-frequency harmonics are wild. Anyway, some interesting results there, and I'm not sure how to interpret all of them. So let's just cut the crap and listen to it. I've got a test mix lined up, which I've already limited with my usual FabFilter limiter. I gave it plus 10 dB of input gain, with a 1 dB true peak ceiling, for an overall loudness of a little less than minus 10 integrated. So relatively conservative settings, with about 5 or 6 dB of gain reduction for the loudest peaks. A quick note about how I arrived at those settings. The first consideration was, how loud can I push it without hearing any change at all from the limiter? It's quite easy to find that setting with the FabFilter limiter, as there's a 1-to-1 option which removes all the gain boost, so you can toggle bypass and hear exactly how the limiting affects the sound. This makes it very easy to find the setting at which you start to hear the limiting, so you can back it off till it's transparent again. And you've now found the optimum loudness for the mix. Note that the meters still show the loudness with the gain boost, so you know how loud it will be when you turn 1-to-1 mode off again. That's a feature that I argued for quite strongly during development, and I'm very glad I did, because it's really useful. And it's only possible if the metering is built into the plugin. You can't do this with a separate loudness meter. My other consideration is the loudness okay relative to the other songs on the album? I'm going to release this as a single so that I can pop a Bandcamp link in the video description. But I still want this release to work well in a playlist of my other releases. Minus 10 LUFS is at the louder end compared to my back catalogue, but this is meant to be loud, it's not a gentle ballad, so I'm going with that. Now let's match that with the LAAL plugin, and immediately we run into a few inconveniences. Of course there's no loudness metering, because the hardware doesn't have it. Of course the output gain is still calibrated in dBu instead of dBFS. Oh, for full scale. Of course there's no equivalent of the equal loudness monitoring option in ProL2. You're going to have to do all of that manually, and you won't know how loud you've managed to make it until you turn the output gain back up. Fortunately, I can skip that for this test. I'm just going to match the input gain boost and the output ceiling and see how good I can make that sound. Even that is not entirely hassle-free though. The moronic dBu calibration meant I had to play the whole song, note the maximum true peak level, then adjust the output gain trim to make sure I had 1 dB of headroom. And I didn't only have to do this once. Any change to anything else, like the release time setting, or any minor tweak to the mix that's feeding it, results in a difference of a few tenths of a dB in the resulting true peak levels. This is unlike any other digital brickwall limiter I've ever tried. Usually you can set the maximum ceiling with absolute precision, with the only question being whether it's limiting true peaks or only sample peaks. But the LAAL plugin has a certain fuzziness and vagueness in this regard. Another example of this, the Pro L2 limited mix hits the -1 dBFS ceiling immediately as soon as the drums kick in. The LAAL, on the other hand, doesn't hit -1 till halfway through the song, and even then only in one channel. The other never gets there at all. I have a theory as to the reason for this vagueness. I think it's fairly safe to conclude that the analog delay line is not completely transparent, and that little bit of colour is modelled in the plugin. And we know that the sidechain doesn't get delayed and therefore doesn't get that colour. If the limiting is driven by a signal with slightly different peak levels to the signal that's actually being limited, that's going to mean slight inaccuracies in the gain reduction and slight variations in the maximum peaks. I think I found a reference to this behaviour in the blurb for the analog hardware.
When you look at the waveform after LAAL processing, you will find your master still lives. It has an air above.
Way to turn a flaw into a feature, I guess. Anyway, with the input gain set, the next task was to pick a good release setting. I ended up with the second slowest, 50 milliseconds, because all the faster settings sounded too distorted to me. And I'm going to have to make the observation here that at these levels I can't really make the FabFilter limiter distort audibly at all, regardless of my settings. So let's have a listen. Well, the LAAL is okay, I guess. It hasn't completely ruined the mix. But it's softening the transients more than the FabFilter, and it's a lot crunchier and more distorted sounding. If I didn't care about the subtler artifacts, I could push the FabFilter limiter a lot harder. But the LAAL feels like I've already reached the maximum, or maybe slightly exceeded it already. And the mix is still below -10 LUFS integrated. If your goal is to squeeze every possible fraction of a LUF out of your mix, this probably isn't the limiter for you. Alright then, maybe I can fix the softer transients issue with this dynamic transient option. Well, that has made the transients a bit more prominent, but they're still not the same as the FabFilter. The transients feel more processed with the dynamic transient turned on. While the FabFilter transients sound more natural and less processed. Dynamic transient feels like covering up the stink with a spray of deodorant, while the FabFilter feels freshly showered and clean. While we're talking about transients, let's get sidetracked by the mid-side option. Normally I'm a big fan of mid-side processing, but unfortunately it doesn't really make much sense in a brickwall limiter with stereo outputs, for the simple reason that as soon as you turn it on, it's not brickwall anymore. If your mid-channel is limited up to full scale, then adding the side channel to create the left channel, or adding an inverted side channel to create the right channel, is pretty much guaranteed to create overs. This doesn't make it completely useless. You could do most of your limiting in mid-side, then run a stereo instance of the LAAL plugin after it to catch those little stereo overs. Don't worry, that doesn't mean you have to buy 2 of the hardware units to use them properly. The MS option is a plugin-only feature. However, if it's okay to have plugin-only features, why can't we have loudness metering and an equal loudness monitoring option like the FabFilter? And why on earth can't I set my output ceiling in dBFS? Anyway, how big a problem is the apparent lack of oversampling for the limiting, especially considering how crunchy and distorted it can get? Let's try turning on Reaper's built-in oversampling. And I can set this to the maximum 16 times oversampling with no problems. So the LAAL works fine with a project sample rate of 768 kHz, which seems like going above and beyond. Anyway, here's the LAAL with no oversampling. And here with 16 times oversampling. Hear the difference? According to Wikipedia, it's impossible for a human being to sink all the way into quicksand. Similarly, it's highly improbable, if not actually impossible, that the reflected aliased harmonics will be higher in level than the harmonics and sum and difference partials that you're adding below Nyquist. And that's even more true when the distortion you're adding is predominantly affecting the lower frequencies, which seems to be the case here. Speaking of distortion, shall we test my theory that the FabFilter can go a lot louder than the LAAL? Here's my Pro L2 setting from earlier, but with an extra 4 dB of input gain, which brings the integrated loudness of the whole mix up to -8 LUFS exactly. And here's the LAAL with the same input gain. That's crunchy as hell. But also, this results in a 0.6 dB increase in maximum true peak levels, and only manages to get the integrated loudness up to -10 LUFS. A whole 2 LUFS quieter than the FabFilter with the same input gain. The lower loudness readings tell me that the average release times are a lot slower with the LAAL. And the fact that the FabFilter limiter can have faster release times and simultaneously less audible distortion tells me it's got way more intelligent program dependency going on in there. I'm going to kind of ignore the transformer option, perhaps controversially. First of all, the harmonics from the transformer are way more subtle than those from even a modest amount of limiting. But more significantly, this is the wrong place in the chain to be adding deliberate harmonic distortion, in my opinion. My personal approach to mastering is to get everything sounding as I want it earlier in the signal chain, then to aim for transparency in the limiter, to get that sound louder without effing it up otherwise. Obviously, it won't make any difference to the sound if your transformer emulation is included in the limiter instead of being in the previous plugin in the chain. But it does mean that turning off the limiter changes more than just the loudness, which is a problem for vinyl masters. To be clear, I don't do actual vinyl mastering, and as I said earlier, I've never actually cut a vinyl record. It's not possible for me to set the correct loudness for vinyl masters, because that will depend on the total running time, and anyway, I'm providing digital files and there's no standard reference level for the conversion. But I do know that limiting and clipping is not helpful for vinyl, and might actually result in a quieter cut. So when I'm asked to provide vinyl-ready masters, I can just turn off the limiter, and if that limiter is set to be transparent, the results will sound identical to the streaming files and the CD versions, just quieter with more natural vinyl-friendly peaks. I know some people sometimes claim that the final limiter can contribute to the sound in a desirable way, but I don't really buy that. I think this is the classic causation versus correlation fallacy. People observe that some mixes just seem to be louder than their peers, even after normalising. And they also notice that those same mixes are often unusually loud before normalising, and they assume the former is the result of the latter. I don't think that's what's going on at all. The reality is, a really good mix can often be pushed louder in mastering without unpleasant artifacts. That optimum loudness I mentioned earlier is higher, simply because the arrangement is on point and the mix is flawless, and every single element has space that it can occupy, even when pumped up to maximum loudness. When that mix is played on streaming platforms with normalisation, it seems to pop out of the speakers louder than other mixes because the arrangement is on point and the mix is flawless and every single element has space that it can occupy, even when pumped up to maximum loudness. It seems loud after normalisation despite the limiter, not because of it. In the case of the LAAL, I actually quite like the type of distortion the limiter adds. If my example was a rock mix that needed to be a bit hairier, I could easily imagine that low-end growl from the LAAL would be just the ticket, and would make an exception to the rule. But in that case, it would be the distortion that was adding to the sound, not the limiting, and I still prefer to do that earlier in the chain, or better still, within the mix itself. Which brings me to what I consider the optimal use for the LAAL plugin, as a colourful mix limiter, not a mastering limiter. Here it is on the half-time drums in the middle section of the song. Running in mid-side mode, because it doesn't need to be brickwall in this context, and that sounded cool. It's doing exactly what I wanted. And maybe this would also be the optimum use for the analog hardware, by which I mean inserted into a digital mix via some spare I/O and your DAW's insert plugin. That way the latency could be compensated just like a plugin, and you could easily run it mid-side if you wanted. Would the hardware sound better than the plugin? No idea. I'll have to wait for Hum Audio to send me my free unit, LAAL, or should I say LAAL? Right, before I go, a quick word about the music. I know there's a significant proportion of you that hate my example music and think it just sounds like noise. What can I say? I'd rather be a bad musician than a I know I've lent into this for comedic effect at times, but let's be absolutely clear, I'm proud of my music. It sounds exactly as I intended it to sound. If you don't like it, that just means you're not ready for it. However, this doesn't extend to the cover art. Yes, it sucks. My talents in visual design are the inverse of my musical abilities, and I've never been able to care how things look in the same way that I care how they sound. I kind of thought my cover art improved when I gave up doing it myself and started using generative AI instead, but some of you disagree with that too. Finally, one of my viewers did more than just moan, stepped up to the plate and designed some proper human artwork for me. So big thanks to Marko Voutilainen, with apologies for almost certainly pronouncing that wrong. This is way better, right? Even I can see that. So if you're adventurous enough to click the Bandcamp link down below, at least your eyes won't be assaulted at the same time as your ears. That's all. Thanks for watching.